Hello students, we are solving a question from Newton's laws of motion. This has appeared in 21st January, shift 2 of JEE Mains 2026. The question says, a large drum having radius capital R is spinning around its own axis with an angular velocity omega as shown in the figure. The minimum value of omega so that the body of mass capital M remains stuck to the inner wall of the drum. Taking the coefficient of friction between the drum surface and capital M as mu. So we need to find the minimum value of omega such that the mass does not slip on the inner wall of the drum. You can see the figure over here. The mass is moving in horizontal circle as the drum spins and it's remaining stuck to the wall of the drum. The forces acting on it is mg downwards, which is trying to pull it downwards. The friction upwards, which is trying to keep it stuck to the wall, and the normal reaction on capital M. So the idea we'll use it, since the mass capital M is moving in a horizontal circle, only any horizontal force can only give it the centripetal force. So the only horizontal force in this question is normal reaction. That must be giving it the centripetal force. So we'll write the normal reaction is equal to F centripetal, or normal reaction is equal to m omega square r. This is equation 1. Next, what will happen? We also need to consider that sum of y forces should be 0. The mass does not slip vertically, right? So we can say mg must be equal to friction. And that means what? Friction will almost be less than mu n for no slipping. For no slipping condition, the friction must be less than mu n. So mg must be less than or equal to mu n. So mg must be less than or equal to, we'll substitute the value of n from here. Mu times m omega square r. You can cancel out the m on both sides. You'll get omega square should be greater than or equal to g by mu r, or omega should be greater than or equal to root of g by mu r. So minimum value of omega is root g by mu r, this shows, which is option 1.